Welcome to my YouTube channel. I am Vibhasant Reddy, and today we will be discussing a machine learning algorithm that is logistic regression to predict rock and mine predictions. We'll be using a Kaggle dataset, that is Sonar mine dataset. In this dataset, we have the target columns that consist of uh, R and M values. These are the strings. That is, R is nothing but rock and M is a mine. Mm, you can download our dataset from here. I will also provide my GitHub link and then the dataset link in the description. Uh, this dataset has like 61 columns over here. You can just download it, and now we'll be using a Google Colab over here. You just need to upload your dataset over here, that is Sonar dataset, and then once it is uploaded, we can start the by importing our libraries. Here we will be importing our libraries, that is pandas. First we'll be importing pandas to handle our data, and then numpy arrays, and then we'll be importing our sklearn, that is scikit-learn, our model evaluation, that is model selection, import our train test split. From matrix we will be importing accuracy score, and then from sklearn matrix we'll be importing our logistic regression from linear model. You can just run the model. Here, the sklearn provides a train test split thing to split your data set, and then accuracy score is nothing but we are gonna it is nothing but the difference between your predicted value and the actual value. And this is the logistic regression algorithm. Like it is a binary classification. The binary classification is nothing but like zeros and ones, that is yes or no, or like it has a spam or no spam email. That is nothing but a binary classification. This is a supervised machine learning. First, let us start by importing our data, that is data collection. We are going to define a data, and then we'll be using read CSV to read our CSV file. It is sonar data.csv. You can just import our dataset. Here I have imported the dataset by using read CSV pandas file, and then here I have given the header as none, which is nothing but in the data frame, that is in the original data, there are no column names. That is, as you can see, there are no column names over here. So for that sake, we need to provide, that is there are no column names, that is header is equals to none. I'll just make it as an hand. It just provides you 5 rows. Now we can just see the shape of our data. Here we have 208 rows and then 61 columns, and then we can even use the info. We can get the information about our data set, like even it says like it's 61 columns and then 208 entries. Like all our columns data types are like float values, that is 64, and then we have one object, that is object is nothing but a string in this CSV file. Object we also known as like string. As you can see, yeah, the last file, that is 60th column, we have these thing, that is r, okay, there are just R over here. Like I think so. In the coming, like there are even M. It is R. Like as you can see, there are R is nothing but rock and M is nothing but mine. And then we can even describe our data. Uh, Here it shows the count and then the mean values of all the data sets, that is by the column, and then standard deviation, minimum value, 25 percentile, and then 50 percentile, and even the max value uh, for all the columns. Next, we want to make sure like there are no missing values in our data set. For that, we can use is null to identify whether there are any null values in our data. As you can see, like it in our data set there are no missing values. That is, it shows like 0 0, which is nothing but there are no missing values. That's a good sign, I think so. And then mm, data 60 value underscore counts. What this does is, like in the data set we are accessing the column, that is 60th column. We are gonna do the value counts. Value counts is nothing but the number of uh, values in the particular column, that is in the 60th column. That is the M is nothing but mine, R is rock. In M we have like 111 values, entries of mines, and then 97 entries of rocks. It is a data type of int string, as you can see over here, and then 60th. And the next step is grouping our data set. We'll use group by, that is on the 60th, by using mean. Uh, we are using a group by method, that is we are going to group all our mean and that is mine and rock by using a mean function. Here why we are using mean, because we want this is our target variable or a dependent variable. By using this we are going to predict our values, like predict our predictions. Yeah, you can see like it shows like 0.034 and the 0.22 and then 0.453. Oh, I think so, like the difference between this is like good, like we can use these differences to make a prediction. Assigning, now we are gonna assign our target variables, that is x and y. Yeah, x is nothing but an independent variable. Just make it a note. Yeah, x is a feature or an independent variable. But you know, you can use, like I'm gonna use your iloc over here, iloc method, and if you want you can use even the drop method, that you can just drop the particular column, but I prefer to use iloc. uh, what it does is, yeah, over here, like the two columns basically, like if I'll just show you, like if I use two columns, that is the first column is for the rows and then the second column is for the columns. Here what I'm did is, like I'm gonna select all the rows except the last column, that is -1, which are our target variables. Yeah, see, we are gonna remove our or drop our target variable, that is 60th over here, and these all that is from 0 to 59 are nothing but our feature variables or independent variables. By using these features we are gonna predict our target variable or make a predictions. And then we are gonna do same for the y, that is target variable. And just comment y is a target or dependent variable. Even I'm gonna use the same iloc method over here, and then just minus 1. Yeah, it means like we are just considering only the last element, that is the last column in our data set. Print our data set. Yeah, over you can see this is our that is the 60th column. And then just delete these cells. Now we need to split our training and test data set. That is done by using these four variables, that is x train, x test, y train, and then y test. This needs to be in the same specific order, and then we are gonna call our train test split method, and then here we're gonna mention our independent variables and dependent variables, that is x and y. And now in this, as you can see over here, like we have shuffle, train size, test size, and then stratify. Now we need to specify our training size or test size. Okay, we can specify our test size as like 0.2, and then satisfy as y, and then a random state we can just specify it like 1 2, it depends upon us, like how do you want to, like what random state is nothing but like it makes sure that the data is shuffled perfectly. Like we don't want like data that is train and test to be inconsistent, so for that sake we use random state. And then same for the satisfy, we are going to apply predictions for both train and test. We can just print our data if you want. Yeah, that is x dot shape, and then x train dot shape, then x test dot shape. Okay. Oh, extreme is not defined. Extreme. I just need to run this. Yeah. Yeah, as you can see, our original shape, that is original data set, it has 208 entries and then 60 columns. And now we are gonna as here we have said like test size 0.2 split, that is we are doing 80-20 split, that is 20 for the test data set and then the 80 for the train. For that sake, what it did is like for extrain it took 116 166 and 60 columns, and then for extrain it took like 42 uh, extraining data sets. And here you can do same for the y. You can just test it. Yeah, it does the same thing. It took like 166 for it to, yeah. And then the next thing is we need to train our model. That is done by creating an instance, that is logistic regression. We are going to call logistic regression. We are going to load our logistic regression in our model, and then we need to specify our model fit, that is x train and then y train. Here we're gonna fit our training data set and then x training data set and the y training data set. mm, yeah, as you can see, it has been completed, it has been done. And like in the next video, like I will show you like when to use fit. Like there are four types, that is fit, transform, fit, transform, predict, and when to use all this one. I will make a separate video for that one. uh, and then we are gonna do a model evaluation. Extreme predict model. Here we're gonna use our predict function, that is on x train, and then that is training data, accuracy, then our accuracy score on x train, and that is this one. We are going to make our accuracy score based on our output that we have received, that is extreme predict over here. Yeah, extreme predict, and then our y train. We are going to compare our accuracies, extreme and then y train. Yeah, and then we can print our accuracy. Oops. Okay, I just deleted. Okay, okay, I'll just type it again. Yeah. Extreme predict, and then training data set. We are gonna use our accuracy score by using our extreme predict and then y train. We can print our data like our training accuracy over here. We can use dot format to print our data. Yeah, as you can see, our data accuracy, that is our training data accuracy, is like almost 80%. I think, which is really good. 80% is really good on our data set. Yeah, and then we are gonna do our accuracy on the test data, that is x test predict. This is a variable, and then we are gonna call our predict function. Here we are gonna use our testing data, that is x test, and then we are gonna make accuracy prediction, that is ACC RCY accuracy score. Here we are going to use x test, because this is we are going to predict our test data accuracy, right? So for that sake we need to do x test accuracy predict, and then that is this one, and then y test. And then even we can get our can just print our accuracy for the testing data. Yeah, it's like almost 83%, I think so, which is almost good even on the testing data. It's almost like similar for both training and testing. Now what we're gonna do is we want to predict like what is exactly, like whether it is an R or M, that is whether it is a rock or a mine. For that sake, R is nothing but rock and M is mine. First we need an input data basically, so we are going to create a variable input data. Now we need to change our input data to a numpy array, like in the that is in most of the data is like in our pandas data frame. So now we want to change to data that is in numpy format, that is input data as numpy. We have this function that is as an array. As array, we can just give the argument that is input data uh, to numpy array. Now what we want to do is like we want to shape our reshape our input data so that our model can predict it. So reshaping our data. This can be done by using a reshape function, that is we can just do it by using input data reshape function. Yeah, that is input data. We know we are going to need our input data, that is numpy, and then we just need to use function that is reshape 1 comma minus 1. Why we did 1 comma minus 1? Because if this is rows, and consider this is rows and columns, like if there are one row, then we need an exactly one column for that one. For that sake, if there are 6 rows, and then we need 6 columns for that. For that sake, we did this reshape. Now we are going to make our predictions. The prediction equals so we are going to call our model function and then predict. This is the model, like as we are defined over, that is model over here, that is logistic regression, and then predict based on our input data reshape input data underscore reshape, then we can just print our prediction. Now we need to get our input data. We can just open our data file. That is Sonar data. You can just get any file. I'll just copy any file. Yeah. And just you can place it in our data input data and just run the file. You will get R, which means that this is nothing but a rock. And if we take like another example, text editor, like as you can see, I just say it's in rock. If you want to consider like other example, that is m, you can just take m data set. It is yeah, over here, like this is the m ones. You can just take this input data and then we can just place it over here. Mm, let's hope like it predicts the correct output. Yeah, this predicted m, that is nothing but mine. This is our prediction output. So this is the uh, prediction algorithm for rock and mine sonar dataset by using Kaggle dataset. Yeah, and then you can just make any changes if you want. You can just even add hyperparameters as your assignment thing. Yeah, uh, that's it. Thank you everyone